Okay, let's talk about elements. Elements that make up those compounds that are going to turn out to be so very important when we discuss energy. In particular, we have, as you see here, a periodic table of the elements. I think most of you have seen this guy before, and we're going to do a couple of little activities in this module that help you get acquainted with the periodic table of the elements, because the various elements and their properties determine the compounds that are formed throughout the universe, but especially like on this earth and in particular ecological systems. The atom, an atom of each of these elements is the smallest particle that holds the properties of those elements. We mentioned that in the previous video. And an atom, I'm going to redraw this. An atom looks roughly like this. We actually model an atom kind of like this, where we have electrons. This is an electron orbiting, sort of zipping around. It's not really an orbit like our planets orbit the sun, but these electrons are zipping around the protons and the neutrons in the nucleus. So we have protons and neutrons in the nucleus. And each one of these subatomic particles has a charge. So protons are positively charged, electrons are negatively charged, and neutrons have no charge at all. This is important because right here, opposites attract. We have a proton, which I'm going to symbolize with a plus sign because it has a positive charge, and an electron, which I'll symbolize with a negative sign or minus sign because, negative. They will move toward each other until they are connected or right next to each other, which I'm going to What do you think happens if you have two electrons? They're going to get as far away from each other as they can. Maybe they run into another proton and decide to hang out with that proton. Maybe they run into another electron and they zip off in another direction to get away from that electron. But opposites attract. Like charges repel each other. And opposites attract. This is the basis for all of life and all of matter in the universe as we know it. These electrostatic attractions or repulsions determine what compounds form and when, and how they behave once they are formed. And we're going to see that in the next couple of days. Okay, so I'm going to give you a little assignment to do on this website. Hold please. I get to, where am I? Where's the PhET? Oh, it's here. We're going to build an atom. And this link will be in Google Classroom. We're going to select the symbol activity. And what we're going to do is we're going to just add protons, neutrons, and electrons and compare to what we see over here in the upper right in that periodic table. So if I take a proton, notice it gives me the name hydrogen. It tells me that it's an ion, a positive ion. Because why? Because so far all we have is a proton and no electrons. If we put an electron, if we add an electron, now we have a neutral atom. Notice in the upper right of the screen, the symbol H is highlighted in the table. It shows you where hydrogen is in the periodic table, and the symbol is shown below that. What do you think the 1 and the 1 on the right-hand side, on the left-hand side of the H mean? Well, what happens if I add another proton? Well, as it turns out, I have a different element. But my numbers on the left-hand side have changed to 2 and 2. What do you think that's telling us? Let me add another electron. And notice now that the charge in the upper right of my helium symbol is 0 because it's neutral. If I take that electron back, now I have a positive charge because I have 2 positive protons and only 1 negative electron. What happens if I add a neutron? Well, nothing happens to the element. It's still helium. And nothing happens to the charge because neutrons are neutral. Add another neutron, same deal. Add another neutron, same deal. Nothing changes there. I'm going to put my my electron back because I would like a neutral atom. So I just wanted to show you how to navigate this particular page. I will provide the link and the instructions for what I want you to turn in with this activity in Google Classroom. Oh, please don't take too long. There we go. So that's the activity. You're going to turn in a little table, which again is in Google Classroom, and you're going to note the element symbol, the number of protons, the number of neutrons, and the number of electrons in a neutral atom. So you're going to build atoms for a few different elements. Then, as I said, we're going to get to know the periodic table. There's another fun little activity on another website also that I will share with you. Here we go. It's a periodic table activity. After you have done the build an atom, we're going to go to this site. And can I scroll up or down a little? Here we go. Select the second tab. You have the introduction tab. Here's the main group elements tab. And you see you have a lot of different colored balls that show up. Well, we have to figure out where these balls go, all of these little spheres. Where do they end up in our periodic table? And you're going to notice some patterns, hopefully, right away. At first, it'll be trial and error. You're just going to stick things in the wrong place. And then you're going to notice some patterns. And once you do, it'll go pretty quickly. And then I'm going to ask you a few questions about those patterns. So let's just try a couple. Let's say I'm going to take this brown sphere and put it right there. Nope. Right there. Nope. Let's put it in the first column. Okay, it stays in the first column. So I know this goes in the first column, but the chemical symbol does not show up. So I have it in the wrong box. It's in the correct column, but in the wrong box. So let me move it down. Yep, there we go, rubidium. RB shows up. I know I have that in the right place. Let's see. Let's try something pink. Nope, wrong column. Wrong column. Right column, but the wrong box. If it stays, it's in the right column, or in the correct column. But if the symbol doesn't show up, it's in the wrong box. I'm going to try, whoops. Let's try down, nope. Maybe, there we go. Silicon. Boom. And so you're going to do this. You're going to complete the table. You're going to move all of the spheres into the correct boxes, and you're going to take a screenshot and turn it in. You're also going to answer a couple of questions about this. Again, the link is in Google Classroom. I just wanted to give you some instructions and help you navigate both sites before you get started on those activities. We'll talk more about this in the next video.